Hello YouTube! Yep, you just be picking off from where we left off in our last video. We were talking about how to calculate changes in U, internal energy, yeah? So again, how do we start? We start with the math bit. And obviously we want to use temperature and either pressure or volume. So let's just write both down first. Alright, so now we have written it down. What do we do? Pick the easier one, right? This is actually just CV. So we just use the first one. Right. So now, what do we need to do next? We can measure this, this, and this. But what is this? Del U, del V, keeping temperature constant. How do we do it? You probably want to use the first law, or one of these relations here. Because out of the many, equations you can use, we have already used math, the math bit. So you probably want to use the first law. So this is why we are using this. So it needs a math and the first law, something like that, yeah? So to make this look like this, we divide everything by V and keep temperature constant. So del U, da da da. Alright. Hope that wasn't too difficult. This one becomes 1 and yep, you get the drill. Alright, so we have this, which we can just substitute back in here. And there you go. du equals cv dt plus whatever this is. And dV. So again, heat capacity measurement, pressure change with respect to temperature, that pretty much gets you U. There you go. You have U. Alright, moving on. Entropy. Changes in entropy. So again, out of temperature, pressure, and volume, this is inverse of density as I said before, rho. Yep. There you go. Much better. So, what do we use? We probably can use all three of these actually. We definitely want to use temperature because entropy has a lot to do with temperature, because at higher temperatures your system gets more and more disorganized. But this and this, yep, you can use either one. You'll see why. So again, let's write this down. Alright, and the other one, which is the pressure one, S del P dP. There you go. So now what do? We notice that these two actually you can find in the Maxwell relations. And this part right? You just substitute this in here, you substitute this in here, and this part's okay. You can measure these things, PT and V. So what about these? Where have we seen them before? So if you're not sure what equations to use, you can see what we have already used so far. We have used the math part, we've used Maxwell, but we haven't used first law. So what's the first law? And if you want to include enthalpy in the first law, then this is how it'll look like. VDP. There you go. So again, you want to like make things simple. You want something like this and this from this. So to make things simple for us, you know, we can use you have a ds here, we have a dv here, so we can actually, oh, wrong one, sorry. We have a ds here, dt here, keeping volume constant. So the general rule of thumb is that we want to keep things as simple as possible. The more you can simplify the equation, the better. So this has volume, this keeps volume constant, which kind of makes this 0 under constant volume. So under constant volume, yep, nothing wrong so far. So let's bring this here. So let's divide everything by del T. Right? Oh, what is this? CV. So CV over T equals to del S del TV. Not too bad, yeah? So the first one we have solved. Oopsie. ds equals to CV over T dt plus del P del T V dV. Get that right? CVT and del P del TV dV. Alright. You can see it clearly here. Let's just move this up a little bit. Alright, so now the second one, we do the same thing with this equation. Keep pressure constant, and what do we get? We divide everything by dt, keeping pressure constant. And what is this? Cp. Yep. Cp over T equals to del S del T P. So let's move on to the next page. ds equals to Cp over T dt minus del V del T P dP. Let's double check. This we get from what we did just now in the first law. This we get from Maxwell relations. Okay. Okay. So with these two ds formulas, question is, which one do you want to use? Alright, which one do you want to use? So I mean, the simplest answer is whichever is more convenient. If you have the data for that, just use it. Alright, okay, thanks for watching. So next video we're going to talk about Gibbs free energy, Helmholtz free energy. Thanks for watching.